Today, we're going to clean a messy dataset using SQL, addressing the kinds of issues you'll actually see on the job. And we'll do it in a way that doesn't accidentally delete all your data. So let's get started. So I've loaded a messy dataset into this table, survey responses. I'm using Postgres for this tutorial, but a lot of what I cover will translate into other databases as well. If you want a video on how I set up Postgres and how I loaded this table in, let me know and I can create that. So let's take a look at this table. So you'll see that this table contains survey responses from customers. So we're collecting a customer ID, contact information, if they're a rewards member, when they took the survey, and then the actual survey responses. And while we're looking through this table, we'll see already that there are some issues. So first here, you'll see that email is populated for some rows and phone is populated for other rows. There may be a way to collapse this information into one column so that it's easier to view. You'll also see here address is all in one field. We could split this up into like a street, city, state field. Rewards member seems to only have the values of yes or no. However, sometimes they're capitalized differently than at other times. So we'll want to standardize this capitalization so that this rewards member column only has two unique values of yes or no. You'll also see the survey date has slightly different formats for dates, so that's something we can clean up. Service feedback may be able to be categorized as well. And in this free text response, you'll see that there's a lot of like leading spaces in some of these responses that can be cleaned up. And as I'm looking through these rows, I'm also seeing sometimes a customer ID appears twice. So we'll have to look through duplicates and see if that's something we can clean up as well. All right, so now that we have those issues identified, we can start cleaning the data set. But before we actually get to the cleaning steps, there are a few steps we need to do first. So the first thing we'll do is we'll actually create a copy of this original table just so that we always have a reference to the raw data, and then we'll actually perform the cleaning steps on that copied table. So to do that, we'll do create table postgres.surveys.survey responses clean as, and we'll just copy all of the data from this original table. So we'll run that. All right, and it says we have 106 rows selected. And so now if we select from this new table, we'll see that it looks exactly like our raw table because we just created a copy of the data. And on top of this, we'll also run some counts of the number of rows that we see in this table and the number of distinct customers we see in this table. This is so that when we're done with all our cleaning steps, we can compare those two counts to make sure that we didn't inadvertently drop out any customers. Our row counts may decrease, especially if we remove some duplicate rows, but our customer count should stay the same. And that's how we can validate that our cleaning steps were performed correctly. So first, we will select a count star just to count all the rows from our clean table. And we see that we have 106 rows, so we'll just document that. And we'll also count the distinct number of customers that we have. So to our count function, we'll give it distinct customer ID. And we'll just call it customer count from our clean table. All right, and we have 100 unique customers. So when our cleaning steps are completed, we should still have 100 customers in our data set. All right, so now to the actual cleaning. First, we'll clean up that rewards member column and either make all the values uppercase or all lowercase. So let's go with all uppercase. So we will test out the change by just doing a select first. We'll select rewards member as it is right now, so you can see what it was before. And then we're going to use the upper function and give it the rewards member column, and we'll call it rewards member clean from our clean table. So what this function will do is it'll take every value in rewards member and convert it all to uppercase. So when I run this, you'll see here is our old values of rewards member, and here's what it looks like once we pass it to the upper function. You'll see it's all uppercase. We could also do this as lowercase. It's really just a matter of personal preference, or if there's something specific in your use case where you need it all lowercase or uppercase, that's how you decide. So here you can see now all the values are lowercase, but we'll stick with uppercase for our example here. Also, something to keep note of with like text or string values like this, sometimes they can get loaded into your database with trailing or leading spaces. And what that means is that instead of seeing something that looks like yes, if it has leading spaces, you'll see there's a bunch of spaces at the beginning. And if there's trailing spaces, you'll see there's a bunch of spaces at the end. And especially with those trailing spaces, sometimes you can't see them as you're just looking at the value. So it's always good to kind of just wrap this column in a trim function. And what that trim function will do is it will remove any of these leading or trailing spaces that you might see. And here you might not see much of a difference. I don't think we actually had leading or trailing spaces in the rewards member column. However, you will see the difference when we clean up that free text column. And that one you were able to see there were leading spaces at the beginning of those responses. So we'll actually do that next, and we will select the free text response column. And we'll also trim the free text response column. Store that as free text response clean. And here you see the initial free text response. So here you can see there were a lot of leading spaces, but then we ran this trim function on free text response. And you can see those leading spaces are gone. So this looks a lot more cleaner than it does with all of those leading spaces. And if there were any trailing spaces on there, you would see that cleaned up as well. Now, before I make those permanent changes, I'm actually going to start a transaction, which basically means I'm telling SQL, make these changes, but don't lock them in yet, not until I can validate them. If all the changes look good to go, then I will commit my changes. If it doesn't look right, then I will undo the changes or roll back the changes. So to begin a transaction, we use the begin keyword. So we'll run this, all right? And now to actually update this table, we're going to use the update command. So we'll do update this table, and we want to set our rewards member column equal to this version of the column where we've trimmed it and we've made everything uppercase. And in the same update, we can also set free text response equal to the trimmed version of free text response. Okay, so now we can run this. And we'll see 106 rows were updated, which is what we expect because we have 106 rows in the table and we want to update all of them. I'll just make a note here that that's what happened. And we can actually select these two columns from our table, and we can see the changes look like we expect them to look. Now, because they look as expected, we would complete the transaction by running this commit command. However, before I do that, I'll show you what I would do if this didn't look right. Like, let's say we still were seeing mixed capitalization in the rewards member column. What I would do is I would run this rollback command, and you'll see that was successful. And then when I selected these columns, you'll see it looks like it did before we cleaned it. Basically, what rollback did was it undid any changes that I made after I ran began. So the only change I made was this update. I said I didn't like how it looked, so I ran rollback and it rolled back the changes to make the table whatever it was before I ran that update command. All right, but this update did work correctly, so we'll actually begin the transaction again. We will update the table, and this time, since these results look correct, we will actually commit the changes. And now when we look at the table again, you'll see that those changes have been made in the responses clean table. So starting a transaction really just gives us another layer of security to make sure that we're not accidentally making changes to the table that we don't want to make. If we make a change and we don't like how it looks, we can roll back those changes and it's like it never even happened. So making a copy of the table and using transactions are both best practices that you can use when you're cleaning data in order to protect your raw data and to make sure that the cleaning steps that you're applying are getting applied correctly. Now for the rest of this video, I'll just start a transaction here and I won't commit or roll back the changes until I make my very last change of what I want to clean in the data set, just for time's sake. Next, let's standardize that service feedback column. And just so we can look at it, here's our entire table again. And here's the service feedback column. So as we're looking through this, we can see like a lot of the values are just things like good service, excellent service, average service. So it seems like a lot of these values kind of fit into the categories of like good, excellent, average, or poor. And we can probably kind of condense all of these into one of those 4 categories just to standardize it a bit more. Now, to make sure that those are the main values that we're seeing, we can actually select the distinct values in the service feedback column. So let's do select distinct service feedback from our table. And we'll see we have 11 unique values, and it is generally just saying, has the word average in it, has the word excellent in it, or good, or poor. So it looks like those are the main categories we can use. There's nothing else in this table. So to categorize these values into those different categories, we're going to use a case statement. So we will select service feedback, so you can see the original value. And then we're going to do a case statement. If you're familiar with Python or just in general like programming logic, this is kind of like an if-else statement. We will test certain conditions or certain cases. If that case is true, we will do something. If it's not true, we'll do something else. And if none of them are true, then we will probably just return null. So here we'll do case when service feedback, like we'll do excellent first. So we'll get a wildcard statement and we'll do excellent. Now, when we're looking for service feedback like excellent, we're looking for any string that contains excellent in it. Now, the way we've done it right now, SQL will look for excellent with this specific case. So it'll look for values where excellent is all lowercase. However, instead of using like, we can use I like, which makes it case insensitive. So now any place you see excellent, this case will evaluate to true. So if it is excellent, then we will make that value excellent. We can add another condition when service feedback I like average, or I like good, then we will say it was good. And then we can do when service feedback I like average, then we will set it equal to average. And when service feedback I like poor, then we'll set it equal to poor. And we'll also add a final else. If none of these conditions evaluate to true, then we'll just set it to null. We also have to end that case statement, and we will alias that as service feedback clean. And we'll select that from our table. And we will run that select statement. All right, so we're not seeing any nulls here. So that means that we got all of the values, yes, we did. We got a great service, okay. There is a null over here. So that's actually something we can add in to probably excellent. Or you can just keep that as null if you want to, but probably better to categorize it. All right, so since that one is null, we'll actually go back and in this excellent thing, instead of just doing an I like excellent, we can do an I like any, and this will look for a list of values. And if the service feedback value is in that list, then it'll return excellent. So here we can actually surround that by parentheses. We'll create an array, which will hold our list. So it'll either be excellent or where it says great. And now if we run this again, wherever we had that great service, it'll now read excellent. All right, so right here. See, now we have it as excellent instead of null. Now this service feedback column is standardized into 4 different categories. So now that we know that that is correct, we can do an update. And I already ran my begin over here. So this update is already happening in a transaction. So we'll update our table and we'll set service feedback equal to this case statement. And we won't copy this as service feedback clean part because we're not trying to alias it again. We just want the value. And you can see 106 rows were updated. So I'll just make that note here as well, that all rows were updated. And when we look at our table again, we'll see that all the values in service feedback are those categorized values. Okay, so when we're looking at our data set, in general, it's looking a lot better now. The values are a lot more standardized, but there's still some issues. So one that we'll see here is that survey date is coming in as text. And you'll also see that some of the dates are using forward slashes and then some of them are using dashes. So we want to make sure that these are all coming in as dates. And we can do that by casting this column to a date. So we'll select survey date once again, and then we'll do cast survey date as date, and we'll save that as survey date cleaned. So when we run this, you'll see that before survey date was text, but then when we cast it, it's coming in with the actual date data type, and all the dates are now using dashes instead because they're being stored as a date. We'll go ahead and we will update this. We will set survey date equal to this value and that. And when we select from our table, now you'll see that the survey date column is still coming in as text, although the actual slashes are gone from the date column. This is because update doesn't actually change the data type of a column, it just changes the values. So if we actually want to change the data type, we have to create a new column. So we'll do alter table, we'll take our table, and we'll say alter column survey date, and we'll set that type to date. And for it to populate the values with what's already existing in the column, we'll use the using keyword and tell it to use the survey dates cast to a date. Now when we select from our cleaned table, we'll see that survey date is actually a date now instead of text. Now sometimes when you're cleaning data, you might actually, instead of just cleaning the column, actually use a column to create additional columns. So that's what we're going to do for the address column. We'll split this up into a street, city, and state field. In addition to that, we'll also create a new column called preferred contact, which will populate with either the email or the phone number, whichever is filled out for a customer. So first, let's tackle address, and we'll split up the strings in address using the split part function. So we'll select address, and next we'll do the split part function. Now this function takes 3 arguments. The first is the column that you want to split. The second is the delimiter or character that you want to split the column value on. And the third is the part of that substring you want to take. So here we will pass split part address because that is the column we want to split. And the delimiter is going to be the delimiter or character to split on is going to be this comma. And for this first split part, we want the first part of the split on the comma. So we're going to put in 1 here. And that will give us the address street. So I'll actually show you the example real quick. If we take this string and we split it on a comma, this would be part 1, this would be part 2, and this would be part 3. So we'll just copy and paste these a couple more times, and we'll take the second part and call that city, and the third part will be state. Also, make sure your delimiters are surrounded in single quotes and not double quotes. That's an issue sometimes I forget with Postgres. All right, so when we run this, we can see we have the address, and then we have the address street, address city, and address state. So the first part of the string was stored as the street, the second part was stored as the city, and the third part was stored as the state. So now we can actually add this column in, and to do that, the first thing we'll need to do is add in all of these columns, and we're going to use the alter command from before, so we'll do alter table, supply it this table, and then do add column, and we want to add address street as a text column, and I'll just copy and paste this a couple of times. And we also want to add the city and the state. All right, so the table was altered, and then we can run our update. So we're going to update our table, and we're going to set address street equal to what we had up here for street. And we'll do the same thing for city and for state. Right, 106 rows were updated. And if we look at the table again, we'll see that we have address street, city, and address state added here to the end. So next, let's create a preferred contact column using the COALESCE function. And what this will do is it'll take the first non-null value between email and phone. So if a customer has their email filled in, preferred contact will show their email. If they don't have their email filled in, preferred contact will populate with their phone number. So we will select email, phone, just so you can see the original values, and then we'll do coalesce. And to coalesce, we'll pass in email, and then we'll pass in phone. And we'll call that preferred contact. And when we run this, you'll see that when email is filled in, then preferred contact is equal to the email. When it's not filled in, it's set to the phone. Now, there are some cases where we have both an email and a phone number. In these cases, you'll see that coalesce takes the email because that is the first non-null value between email and phone. So really, we're doing the logic this way because we want to contact the customer by email if they have an email, and if they don't have an email, then we want to save their phone number. Now, if you wanted to do it the other way and you preferred to save phone numbers if there is one, you would put phone as the first argument to coalesce and email as the second argument. Now you'll see we still have nulls here in the preferred contact, and that happens when both the values for the columns that you're coalescing are null. You can also add in a third string literal in here called unknown. So then if email is null and phone is null, unknown, the actual string, becomes the first non-null value. And when we run this, you'll see that those null values are now filled in with unknown. So once again, let us update the table. So we'll do an alter table and we'll add preferred contact this time. And we'll update the table setting preferred contact equal to our coalesce statement. And so now when we select from that table, you'll see down here, we have our preferred contact added. Finally, let's go over how to remove duplicated data from a data set. So if we look at the data ordered by customer ID, we can see that some of the customer IDs appear twice. Now, some of these are actually true duplicates, like customer 8, you'll see almost every single value is the same for this person. So it looks like that same survey was just submitted twice. And I'll show you how you can confirm that in a second. But we'll see some of these here that everything looks the same except the survey time is different. So it looks like this person actually submitted 2 distinct surveys. So for them, we would just want to keep their most recent survey. But for the ones that are actually true duplicates, we just want to keep one of the rows and delete the other one. Because in our use case, there's no need to keep that duplicated row in the data set. So first, how can we easily check if the duplicates are actual duplicates? Well, we can count the number of rows that show up with the same customer ID, the same address, the same survey date, and the same survey time. And we'll do that using the count function. So that is going to count the rows grouped by certain columns. So here we'll do select count over partition by customer ID, address, survey date, and survey time as a duplicate count. Now I know that this looks kind of complex, so don't worry, I will explain what that means. All this is saying is that we want to count the number of rows in each group, and this is how we're grouping the columns. We want to group columns by the customer ID, address, survey date, and survey time. So rows that have the same values for all of these 4 fields will be in one group. So in this example, since these 2 rows have the same customer ID, the same address, the same survey date, and the same survey time, those rows will be in one group, and the count of that group will be 2 because there's 2 rows in that group. However, a row like this only has one row where it has this customer ID, this address, this survey date, and this survey time. So in that group, there will only be one row. And this needs to be a count star, by the way, because we want to count all the rows. And we need to select star here so that we'll get all the rows returned as well. All right, so here you will see we have all our columns, and at the end we have a duplicate count indicating how many rows appear with that same customer ID, that same address, that same survey date, and that same survey time. So for these first ones where the surveys were submitted at different times, you'll see there's only one row in each of those groups because they have a different survey time. However, down here where it really is a true duplicate, where it has the same customer ID, same address, and same survey date and survey time, the duplicate count there is 2. So that is an actual duplicate value. It's not just someone that submitted 2 surveys, it's the same survey that got submitted twice. So we can actually just look at all the duplicated values by turning this into a subquery. So we'll put parentheses around that, and we'll select everything from this subquery, and we'll filter it to where duplicate count is greater than 1. So these are all the duplicated rows. So you can see we have 6 rows that are duplicated. So really 3 customer IDs where the same survey got submitted twice. Now we only want to delete 1 instance of this duplicated row. And to do that, we need to flag the row that we want to delete in some way. So we need to be able to uniquely identify each row in this table. And normally a table will have a column that uniquely identifies each row. This is generally known as a primary key. However, in this table, we don't have one. So we can actually create a row identifier for each row. We'll do alter table, give it our table name, and we'll add a column called survey ID, which will kind of act as our row identifier. And we are going to give that type big serial. And that will auto increment the value for each row. So it'll start at 1. So row 1 will have survey ID 1, row 2 will have survey ID 2, and so on. So we can run that, and then we can select again, ordered by customer ID. And at the very end, you'll see we have this ID here as well that uniquely identifies each row. So for customer 8, their customer ID is 8 for both of the rows. However, we can uniquely identify them by the survey ID because it's 10 for the first instance and 11 for the second instance. And now to identify the duplicated row, or just the second instance that we see that's that same data, we're going to do something pretty similar to what we did before with count over partition by. However, this time we're going to use row number and pair that with partition by. So this row number will indicate which time this record appears. So the first time a row in a group appears, it'll have a row number value of 1. The second time it appears, it'll have row number value of 2, and so on. So let's do select. We'll take all of our columns and we'll do row number over partition by, and we want to group the columns by the same thing again. And we're going to order it this time by survey ID. This is how we will get the row number values. And we'll call this survey instance. Okay, so we ran that. And here, let's focus on customer 8 here. At the end, here's our survey instance. You'll see the first time that survey appears, it has a value of 1. The second time that survey appears, it has a value of 2. And the way 1 and 2 were determined here was that it was ordered by the survey ID. So the smaller survey ID got a row number value of 1, and the larger one got a row number value of 2. Everything else here you'll see has a value of 1 because they don't all have this, because that is the only time in the table that that row appears with that customer ID, that address, that survey date, and that survey time. So now to actually delete the rows where survey instance is equal to 2, we're going to first create what's known as a CTE, or a common table expression. This is where you're able to define this query as a temporary table, and you can query from it like it's a table as well. All right, so we'll write the CTE as with duplicates as this query up here. So this CTE will just return to us this table. Now, once we define this CTE, the next thing we write is really just going to query from this table, essentially. Here, we're going to delete from our table, our original cleaned table, any row where our survey ID is in a list of survey IDs from this CTE, which we can refer to as duplicates, that has a survey instance, also our row number, greater than 1, which means it appears more than one time. So we're getting all the survey instances or all the rows that have a row number of 2 or greater. So that's the second instance of that duplicated row. So when we run this, we got that 3 rows were deleted, and that seems to make sense because earlier when we looked at all the rows that were duplicated, we got 6 rows returned. So 3 of those were the duplicated rows. And I will write that up here as well, that we had 3 rows that were deleted. So now when we look at our table ordered by customer ID, you'll see that customer 8 only has 1 row in the table now because we deleted that second instance of the exact same survey submitted by the same person. Now you'll still see customer ID 1 and customer ID 2 still appear here twice. And that's because these aren't true duplicates, but these 2 customers actually submitted 2 separate surveys since they have a separate survey time. Now for our use case, let's just keep the latest survey from each person on the same day. So to do that, we're going to do something really similar to what we did before, except now instead of partitioning by customer ID, address, survey date, and survey time, we're only going to partition by customer ID, address, and survey date, and then we'll order by survey time to figure out which row we want to keep. So I'll actually just copy what we had before. We'll create the same CTE, but this time let's call it multiple submissions. And I will mention with CTEs, this table-like structure is only valid for this query. I can't query duplicates here again because it doesn't exist for this query down here. So now we're selecting row number over the customer ID, address, and survey date, but now we'll order it by the survey time. And we'll call it survey submission. And we want the most recent survey to count as our first survey. So we'll actually order this in descending order so that the most recent time will get a row number value of 1 and the earlier survey time will get a row value of 2. So I'll actually just run this so you can see what I mean. Okay, so now we calculated the row number by the customer ID, the address, and the survey date, and then we ordered it by the survey time. So here you can see this survey was submitted later, and so that will have a survey submission of 1, and that earlier time has a survey submission of 2. All right, so now from that, we are going to delete from our table any survey ID where the survey ID is in multiple submissions, having a survey submission greater than 1. So in our case, it'll delete this earlier survey for us. All right, and that also deleted 3 rows. And now when we look at our table again, you'll see that customers 1 and customers 2 only have 1 instance in the table, and it is their last submitted survey on this day. All right, so now we've made all the changes I think that we want to make, at least for our use case. Now we can confirm that we didn't accidentally drop out data that we didn't expect to drop out by running those checks again that we ran at the beginning. Remember where we counted the rows and the customers? So let's do those again down at the bottom. So let's see how many rows we have. We now have 100 rows in the table. Before we had 106. And that does make sense because we deleted 3 rows here and we deleted 3 rows here. So we should get 106 minus 3, 100 rows left. And now this one's the more important one. Let's see how many customers we have. We still have 100 customers in the data set, which is what we expect. Now that we know our cleaning steps didn't negatively affect the data or take out any data that we weren't expecting to take out, we can commit our changes. Remember, we started that transaction a few updates ago. We'll commit our changes, and now our table is cleaned and ready to use for any analysis that we might want to do. All right, so that is how you would clean a data set using SQL and how you would make sure that you don't accidentally delete any of your original data. Now, depending on your data set and your use case, there's a lot of different cleaning steps you could do, but what I've shown here are just some common issues you really see with your data sets, and I just wanted to show which functions you would use to address those problems. I also recently created a SQL data cleaning cheat sheet that goes over some of the syntax I mentioned here and some more functions. It also gives some tips and things to look out for when cleaning your data sets. And it includes some notes for the different SQL flavors. So if you're interested in that, it is available for a small fee at the link in my description. And you can check that out if you're interested. Thank you so much for watching this video. I really hope it was helpful, and I hope to see you in the next one.